Welcome. This is a time series analysis course. My name is Nicoleta Serban. I'm Associate Professor in the Stewart School of Industry and System Engineering. This lecture is multivariate time series analysis with a focus on a series of data examples using R. In this first example, I will illustrate the VAR model with a case study on predicting total moose population in Alaska. This case study was used to illustrate applicability of the ARIMA model in the previous lecture. In this lecture, we'll consider other factors which may impact the rise or fall of the moose population. The data provide irrelevant factors related to moose population, including population of Fairbanks, which is a city close to the location Unit 20A, from which we have the data on moose population, Alaska wolf population, average snowfall, and moose harvested. The years of the data are from 1965 to 2006, and the data are yearly. The data come from multiple sources, but are particularly acknowledged the Alaska Department of Fish and Game. The time series plot of the forecast of the factors in this dataset are here. We'll focus on the total moose population in this study. We can see that many of the factors provided have some overlapping patterns with this time series. The question we'll address in this lecture is whether we can forecast the total moose population with the aid of other factors. Does the wolf population impact the moose population? Does the moose population tend to decrease with heavy snow? Again, such questions can be addressed with a multivariate time series analysis. In a previous lecture, I developed forecast of the moose population based on two methods for modeling univariate time series: the ARIMA model and the model in which we first estimate a trend using non-parametric regression, then apply ARMA to the detrended time series. The forecasts are provided here along with the observed data for comparison. The model in which we account for nonlinear trend, shown in blue, performs better than ARIMA, shown in red. As pointed out before, it is possible for other factors to impact the moose population. For example, the population of moose predators, wolves, for instance, can be a key indicator of the subsequent year's moose population. In general, a high predator population in a given year will not only influence the following year's moose population, but it also expected to have a more long-run effect. Additionally, natural factors such as weather and environmental conditions play an influential role. Average snow depth for a given year will be used as a measure of how harsh a particular winter season is. The population of the city of Fairbanks, the largest city in the region, as well as the number of moose harvested by hunters each year can reveal the effect of humans on the population of surrounding moose. Can we improve on the forecasting of Alaskan moose population by accounting for such factors? In summary, in this lesson, I briefly introduce the application in which we're interested in prediction of the Alaska moose population, and I will continue in the next lecture with the forecasting comparison between univariate time series models and the VAR model. Thank you.